What I'm talking about today is something called the Tydall Effect. And this is the effect you see a trailing light. Kind of like when you're driving at a foggy night with your headlights on, you see the trail of light. Now most times when you put your lights on, you don't see anything. So if I was to take this solution with this Florence flask, and I was to take a 5 milliwatt of green laser and I shoot it through, okay, you don't see a trail. You may see some reflection because of the bent glass, but you don't see a trail through it because it's a solution, and this solution being a true solution, the molecules are so small that the water is able to actually dissolve the ions. So each water molecule is totally encapsulated around. Now I'm going to give you a little small aquarium filled with gelatin. Same gelatin that's used in our favorite Jiggly Wiggly desserts of Jello. Now, unlike the solution, okay, this is not a solution. The gelatin molecules are so big the water cannot actually surround them, interact them enough to actually encapsulate them. So these big molecules, as I'm showing you, show a trail of a light passing. So you can see that trail kind of like a fog, or your lights on during the fog. So it's called the Tydall Effect. I'm going to turn the lights off. You're going to see this more brilliantly in a second. But again, the reasoning behind this is because, very simply, we have something called a suspension here. And this suspension of particles, it's not a solution, another form of matter, is a suspension because the molecules are so big they cannot be dissolved by the water molecules. But they're still so light, they're not, or they achieve a very similar density, so gravity's not pulling them to the bottom yet. So suspensions we have all over. In this case, we have a solid in water, and this is basically a suspension of the gelatin, okay, like in Jello. And if I was to put back that solution, okay, and shoot light through it, we don't see that trail. And there might be a little tiny bit of some matter in there, but not easily discernible. And again, the bigger molecules that are in the suspension reflect back the light and hits them. Whereas in a solution, where the molecules can be encapsulated by the solvent, the water in this case, okay, it's as if the molecules are not there because the water surrounds them. Okay, and that's called a Tydall Effect. Now I have something called agarose, which you use in gel phoresis, and it would work just like that. And I put a bottle here, okay, and all I'm going to do is shoot a laser through it, and you can see very brilliantly how you can see a line through this. Not only do you see a line, but the light is refracted in all directions because of the big molecules. And these are much bigger molecules that, let's say, are in this gelatin. So agarose, a very thick agarose, again, is a suspension in water. These molecules are too big to be dissolved, so these gels will glow the light very brilliantly. Okay, so let's do one more demonstration to show that, and I'm going to take you back, okay, to the other part of the room, and I'm going to fill most of this room up here with some smoke. So I'm going to put some smoke in the air, and smoke is another colloid. Now, why is smoke a nice colloid? Well, it's small solid particles, okay, that are suspended in the air. Okay, so I've added some smoke into the room, and now I'm going to shoot my green laser, and my laser, just like a nice laser show, should be able to come up. And you've seen these in movies when they wanted to find the laser, they have to what? Jump around in some kind of, let's say, I don't know, movie to, I don't know, get into a vault or steal the something or other, Mission Impossible. Okay, you can see the trail very nicely once that light hits those solid particles. Okay, and here's an example by the cloud. It's emitted by let's get some more smoke in here. So again, you can see clearly that the smoke makes it come up. And you see them spray aerosol cans for the same reason, because this smoke is nothing more than what? A colloid. And that suspended particles is what you're seeing. Kind of cool stuff there. So the solid particles are not dissolved. Remember, gas is a solution, yeah? Remember? All right, I don't know if I can see back into the entire room. It's too dark for to pick it up. But you get the idea. Okay, another example of and let's do that because that was probably a lot of fun. Another example of a colloid would be foam. We got liquid trapped, like a gas trapped in a liquid. So here we go, and there's my laser pointing out the entire room. Hopefully you can see it on my board. You can see that trail, and that's called the Tydall effect. Now obviously as the smoke dissipates, okay, as the smoke sort of dissipates, no longer is there big particles to reflect back out the light, and it disappears. All right, so if I try to give you this perspective from the camera, kind of cool there. Classic Tydall effect, and it's just showing you property of a colloid. A solution, which is regular gas, okay, doesn't do this. All right, because the particles are too small, surrounded by the other particles. Only big particles that are not truly dissolved can reflect back out. In any case, take care. That was what I wanted to show you today.